All right, so I wanted to go over the Pythagorean theorem a little bit. So the Pythagorean theorem, the first thing that we have to know about it is that it only applies to a specific type of triangle. So obtuse triangles aren't going to work. Acute triangles aren't going to work. The only thing the Pythagorean theorem applies to is right triangles. So for this video, again, only right triangles. Before I get into the theorem itself, we're going to kind of see how it works. I think it's good to see a sort of a visual explanation of this before really just trying to throw formulas at questions. So I'm going to draw myself a nice right triangle here. And I'm going to give it these dimensions. Okay. Actually, I'm gonna shift these inside to make it a little bit more easy, a little bit easier. Okay, so a couple things. I'm gonna just label some sides first, so you know what I'm talking about as I go along the video. So the two sides that are shorter and that connect with a 90 degree angle here, we call those legs. So short sides, those are legs. And our long side right here, in this case, our length of 5, we call that our hypotenuse. And hypotenuse is a term that is specific to right triangles. All right, so let's keep going here. What I'm going to do next might seem a little bit odd, but hopefully as we go through, it'll make a little more sense. So I'm going to take each side and turn it into a square with this as one side length for each case. So for example, on my side length 3, I'm going to turn that into a square where each side length is 3. In other words, this is a 3 by 3 square. Okay. Then down here, I'm going to make a 4 by 4 square, just like that. Okay. And I'm going to have to give myself a little extra room here. Went off a little bit, that's all right. So this is going to be a 5 by 5 square. Okay? Now, what's interesting about this? Well, let's figure out the area of each of these and see if we can do something with that. So my first one right here, a 3 by 3 square. Well, my area of a square or of a rectangle just says to find the area, I multiply length times width. So 3 times 3, area is going to be 9. Okay? For my 4 by 4 square right here, well, length times width, 4 times 4, area is going to be 16. Okay? And finally, I'm going to take a look at my last one. 5 by 5 square, 5 times 5, length times width is 25. So the area of this one equals 25. Now if we look at it, there's an interesting relationship here, right? If I take my two smaller areas, my 9 and my 16, and I add them together, I'm going to get the area of my bigger square right there. In other words, squaring all of my sides, and then adding the two smaller ones will get me a bigger one. Okay, and we're going to generalize that, and that's going to be our definition for Pythagorean theorem. So, let's go right up here. In general terms, we're going to call our legs of our right triangle, we're going to call them A and B, and we're going to call our hypotenuse C. And our Pythagorean theorem says that one leg squared plus another leg squared is going to equal my hypotenuse squared. A squared plus B squared equals C squared. So, again, A and B are legs, and C is the hypotenuse. All right, now we're going to actually put this Pythagorean theorem into action. So I'm going to do a couple practice problems just to kind of show you where this might be useful. Okay? And I'm going to start with one that we should already know the answer to because it's a triangle we started with. But let's say that I have this right triangle right here. Again, this only applies to right triangles. So if you try to do this with another type of triangle, it's not going to work. All right, let's say I know this side is length 3, this is a length of 4, and I don't know this one. I'm going to call it, let's call it Z. Okay? So I know, since I'm using a right triangle here, that I'm going to need to utilize my Pythagorean theorem. In other words, the side squared plus another side squared, or the sum of the legs squared, that's going to equal my hypotenuse squared. Let's fill in what we know, and then we can just solve. Okay? So one leg is 3, so a squared, that's going to become 3 squared. My other leg, well, that's 4, so we're going to say plus, we're going to say plus 4 squared. And my hypotenuse is z. It's just a variable, so we're going to put that in for our hypotenuse. We're going to say z squared. Now it's just a matter of remembering those solving equation methods that we learned earlier in the year. Okay, so let's simplify. 3 squared, 3 times 3 is just 9. 4 squared, 4 times 4 is 16. And z squared just stays the same. 9 plus 16, that's going to be 25. Equals z squared. Now, we're trying to find z, not z squared. So we got to think back to our inverse operations. Z squared, if I want to get rid of that square, I have to do the opposite, which is just taking the square root. So I'm going to take the square root of both sides. And even though taking a square root gives you a positive and a negative answer, typically, because we're dealing with length, we're only going to use the positive answer here. So square root, or the positive square root of 25, that is 5, and the square root of z squared is just z. So that means our hypotenuse length, that's going to be 5. All right, so let's try another one. So the one we just did, our hypotenuse was our unknown. And that's a little bit easier to do because I can just sort of plug in the values for the legs. I get, combine my leg terms here, find the square root, and I'm done. But not all of the Pythagorean theorem problems that we deal with are going to be like that. Sometimes we're going to have an unknown that's one of the legs. So I'm going to just grab a example problem here. Let's try this one. So we're going to do, we'll say 5. We'll call this S, and we'll say this is 13. In other words, one of our legs is 5, one of our legs is, we don't know, we're just calling it S, and our hypotenuse is 13. We're going to have to use our Pythagorean theorem because we're dealing with a right triangle. 90 degrees right there. So let's go ahead and do it. So a squared plus b squared equals c squared. Sum of the legs squared equals the hypotenuse squared. And let's fill in what we know. So one leg is 5. So I'll put that in for A. And it doesn't really matter if I put in 5 for A or B. They're both legs, and the order doesn't matter here. We just have to make sure that both of the legs go in as A and B, not over here. Okay? That means my remaining leg is S. It's unknown, so I'm going to just say that's S squared. And we're going to say that's equal to 13 squared because C is just our hypotenuse. Okay? Let's simplify this out a little bit. 5 squared, that's 25, plus S squared equals 13 squared, which is 169. Now, what we want to do here is kind of just think back to our two-step equation strategies, where I need to notice, okay, I've got a constant over here with my variable term, and I got to get rid of this because I'm trying to isolate S. I'm trying to get S on its own. So I'm going to subtract 25 from both sides, just like that. And I get S squared equals 144. Okay? Then my last step is just to say, okay, I have an S squared. I only want S. Inverse operations, right, to solve. It's being squared. The inverse, the opposite of that, is square root. So the positive square root of 144 is 12. So that means our leg S has length 12. Just like that. The final thing I want you to remember about Pythagorean theorem, just when you're doing problems like this, is to make sure you're identifying if you are solving for a leg or the hypotenuse. Most of these won't be drawn perfectly to scale, but the hypotenuse is always going to be your longest side, and it's always going to be diagonal from your right angle. Because as we saw on this problem in the last problem, it's a slightly different method depending on what you're solving for. But as long as you go through methodically and make sure you're putting in your leg lengths for A and B and your hypotenuse for C, you should be all set.